Let's get right to the point. Why is negative b over 2a the formula for finding the x of the vertex in any quadratic equation? We know that the parabola is symmetrical. Because of this, we know that our vertex will be in the axis of symmetry, also called the middle. Due to this, we know it will lie in the middle of the roots too. We already know we have to divide by 2 this way. Now, how to put the sum of the roots in the formula without putting them there? Luckily enough, we know that b is the sum of the roots, while c is the product of the roots. So now we can put b on top, but why the negative sign? As you know, when factorizing, you get the roots, but first you have to get them to the other side, due to which they flip signs and become negative. To accommodate for that, we put a negative sign in front of the fraction. Why the a though? As you know, when you have a quadratic equation where a is different than 1, you normally divide b and c by a for simplicity. To accommodate for that too, we also divide by a. We have reached the desired minus b divided by 2a formula. Other way it can be explained is by using the quadratic formula. We know only the vertex has one root, and we know that if the discriminant is 0, then there's only one root. This means that when the discriminant is 0, we get the formula for the root of the vertex. Let's see what it is. And it's minus b over 2a. To kind of explain what's going on, think of the root part as a value you subtract or add. Now since you add or subtract the same values, it means the average of these values is in the middle, the axis of symmetry. So when they cancel each other out, you get the vertex. The more you approach the vertex, the smaller this add or subtract value becomes until it hits 0. Next, completing the square. Completing the square was actually not invented to find the coordinates of the vertex, rather it was to make quadratics easier. Think of it like the quadratic formula before the quadratic formula. It was useful because then you got parentheses raised to the second with a number separate of x. Then you could get it to the other side and simply root both sides. Add the second term inside the parentheses to the other side and get an answer. The first question was, how was it derived? The idea can be seen like this. If you could factorize the quadratic in a different way that showed x squared only, thus by itself, then solving would become easier. The idea was then to algebraically move the constants around until you got x squared only, which turned out to be in parentheses. Let's see how it was derived. A note, we will use something called a system, a fancy word for putting rules up. Before I show how we can reach it, let's do the opposite. Let's deconstruct the completing the square formula back to the quadratic model. Let's go through it slowly. First, many of you might not know this version of the formula. That's because all the things you see are taught to you by tongue. They tell you p is b divided by 2 and etc. Well, here it's shown fully. Let's start. First, we use the binomial theorem to expand the squared parentheses. The middle term is 2x times the fraction b over 2a. So we cancel the 2. Then we multiply each term in the resulting parentheses by a, in which b over a gets cancelled to just b, and b squared over 4a squared gets cancelled to just b squared over 4a. Parentheses are now removed and we can subtract normally. As you can see, we just got positive and negative b squared over 4a, which means they cancel. And after that, it's either back to our quadratic model. What's interesting is that it looks like they just added something and canceled it instantly. I mean, we can add anything this way. Why this specifically? Look, in a standard quadratic, c does not have to be a perfect number that manages to give us the same parentheses squared. But now we're searching for that number, the number that will give us the parentheses squared. We're searching for a new c basically. That's a perfect constant, which will allow us to always get a parentheses squared. So we do this thing here. We add one new constant, subtracting and adding it at the same time. Now if we just group things just right, we will see it instantly. Quadratic model, but instead of c, it's y. First step is to remove the a, which is why we get it outside the parentheses. But we do divide b by A and Y by A. Now we use the system to assert rules. We know that in a binomial equation where both parentheses are the same, the middle term is 2ab. A is x here, so we're left with the fraction b over a times x. Let's use the system now to assign that b over a is equal to 2p. Nice, substituted. Next step, the third term is b squared, so y over a must equal to p squared in our equation. Write that in the system and substitute. From this point onwards, it's pretty simple. We just got a perfect picture binomial theorem. Let's factorize it. Look, we got what we wanted. Square parentheses. Minus y plus c sit on the side. Okay though, what do these letters mean? Now's the time to unsubstitute. The system we had still works fine. We said that b over a is equal to 2p. To get p, just divide the equation by 2, giving us b over 2a is equal to p. Substitute b over 2a for the p's that we already have. Then we said that y over a is equal to p squared. We know what p is equal to. Let's calculate that squared. Okay, put it back. Now it's y over a is equal to b squared over 4 times a squared. Now, to isolate y, we multiply everything by a. The a cancels with the a squared, so we get y is equal to b squared over 4a. Let's substitute all these boys back in. Would you look at that? We got the formula. From absolute scratch, by the way. It's a bit hard to understand, so I recommend rewatching it a few times. Now back to the vertex coordinates part. It becomes dead obvious why the x of the vertex is there. Remember how I just explained why the formula for the x of the vertex is minus b over 2a? Well, if you look back at what we did, we factorized. That's the origin of the formula, as I explained as well. Like, it's almost exactly the same thing, just that we don't have c, but y, which behaves the same way. Why the a of the vertex though? Well, first off, what's the formula for the y of the vertex? Well, since we know how to get to the x, we just plug in minus b over 2a as the value of x and do some algebra. Since this is very similar to the steps we did above, I'll just show the animation directly. Well, what a coincidence. This is exactly what we got out of the parentheses. Sadly, I can't really explain to you why this shows up. It's just a result of algebra and stuff moving around. Sometimes there's a very intuitive explanation, but here it's not to be seen. Remember that all formulas are just dependencies. If math was a person, it wouldn't see differences between 2 is equal to AB and this, for example. This is simply the numbers that pop up. It's just not as intuitive. So this is the end of the video. I hope the animations helped. I made them by myself. They're not exactly perfect, but I hope this helped you guys understand what these two things actually mean and how they are derived.